The general quadratic functions can be given in these forms. Now, this is the general form because I have a for the coefficient of x squared, b for the coefficient of x, and c as a constant. Now what a function does is that it maps values for x to values in y, or values for the input here to the output there. It shouldn't be ambiguous where the values of the input map to. If it is, it's no longer a function. Now, quadratic functions, we don't need to worry about that. These ones will always be functions. Now, this is in the general form. Like I said, there's a here, b here, and c here. Let's take a specific example of a quadratic function where a equals 2, b equals 5, and c equals -3. Okay, so if I use these values for a, b, and c, I will get a specific quadratic equation, and it will no longer be in this general form. So let's write that one down. So we've got fx equals 2x squared plus 5x take away 3. Okay, so this is a specific quadratic function, and this was the general. Now, what I will do is I will show using some values for x, or values for my input, and get some output values. So let's use x equals 1. So when x equals 1, I will have the value, so for my output I will have 2 times 1 squared plus 5 times 1 take away 3. Now 2 times 1 squared is 2, and 5 times 1 is 5, so that's 7. 7 take away 3 is 4. So this will be 4. I'll get some more values. So x equals, let's try x equals 2. So f of 2 is equal to 2 times 2 squared plus 5 times 2 take away 3. This here will be 8. 8 add 10 is 18. 18 take away 3 is 15. So here we will have 15. Let's use some negative values this time. So x equals -1, let's say. So f of -1 is going to be 2 times -1 squared plus 5 times -1 take away 3. So this one would be 2 times -1 squared is positive 1, so this will still be a 2. This will be a -5, so 2 add a -5 is -3, and -3 take away 3 is -6. So this will be -6. Let's try x equals 3. X equals -3, let's try. So f of -3 is equal to 2 times -3 squared plus 5 times -3 take away 3. So this time I will write it out again. So I will say this is equal to -3 squared is 9. 2 times 9 is 18. So this is 18. 5 times -3 is -15, and then take away 3. So I'll have add -15 take away 3, and this I can see gives me 0. 18 add a -15, that's 3. 3 take away 3 is 0. 0. So x equals -3 mapped to 0. I will show one more value. We could also have fractions as our inputs. So let's use a half. F of a half would be 2 times half squared plus 5 times a half and take away 3. So here what I would have is half squared is a quarter. 2 times a quarter is a half. Okay, 2 quarters is a half. So this would end up being a half. 5 times a half is 5 over 2. Now this -3, I'm going to make it into a fraction over 2. So it would be -6 over 2. So I can say take away 6 over 2. because I can think of this as negative 3 over 1, multiply the numerator and denominator by 2, you will get 6 over 2 here. So a half add 5 over 2 is 6 over 2. Take away 6 over 2 is equal to 0. Is equal to 0. Now if you remember, I said it shouldn't be ambiguous where values of the input will be taken to the output. So in this case, I actually don't have that. I do have two values here, which both output 0, but when I input negative 3, I know exactly what my output is going to be. It will be 0. If that was ambiguous, if the expression was telling me when I input negative 3, it can be 0 or 5, that would not be a function. But in this case, because when I input negative 3, I know what the output is, which is 0, this is fine. It's the same output for a half. So when I input half, I know exactly what my output is going to be, which is 0, so this is a function. So this is my mapping. So I've got x equals 1, and that outputs 4. X equals 2 outputs 15, negative 1 outputs negative 6, negative 3 outputs 0, half outputs 0. Now I could have used values of y here. So I could have said when x equals 1, y is equal to 4. When x equals 2, y is equal to 15, and so on. So this is the basic idea of a function, and specifically quadratic functions. Now quadratic functions, when plotted on some axes, form the shape of a parabola. So it could be either of these types of shapes, and it could be anywhere on the axis. So it could be here, could be up here, down here. Either one, you could sort of move them around depending on the values of A, B, and C. Now, if the A value is positive, then you will get a parabola in the form of a U-type shape like this one here. If the A value is negative, you will get a parabola in this shape, more like an N shape. And then also, when you think about, consider the values of A, B, and C, that will maybe move the graph in different places. Now, a few points are really important points that we need to know how to find quite quickly. Now, this is the lowest point, and on this one, this is the highest point. You can complete the square and use some of the values to find what the coordinates of this point are, or this one. You can also see that this graph here crossed the x-axis twice, and you can find these values by setting y is equal to 0. So this is my y-axis, y is 0 here, or anywhere along this line. So when you put y is equal to 0 and you solve it for x, you will get this value and that value. Also, you can find this value. This is the easiest one to find. This value is when x is equal to 0, because this is my x-axis. Here you have x is 0. Anywhere along this line, x is 0. So when x is 0, this whole part is 0. When x is 0, this part is 0 as well. So this value here is just the same as the c value. Now, a few other things. If I move this graph up, so if I move it here, you can see that we can have a quadratic graph that just touches the x-axis. So when you solve, when you set y is equal to 0 and you solve it, you will get only one value. You can also have it above like that. So sometimes when you set y is equal to 0, this, you would not be able to solve it for any real values here, okay? And the y value is still there. You'll be able to find the lowest point, and there's no place where it will cross the x-axis or touch the x-axis, so you won't be able to solve this equation when y is equal to 0. And the same can be said about this graph. So if I had moved this graph down here, it doesn't touch or cross the x-axis, so you won't have any real values there. You can touch it once, so you can touch it like that, or you could have it up here or there, and you'll have two values. Okay, so these are a few points to remember about the geometric form of a quadratic equation, which is a parabola, and how they interact with the x and y axis here. Here I have the quadratic equation, and I've set y to be 0. Okay, so I have ax squared plus bx plus c equals 0. We know to solve this, we can use the quadratic formula where x is equal to, we can get either 2 values, 1 value, or no values actually. You find it by doing negative b, and then you add square root of b squared minus 4ac, and you divide all of that by 2a. Or you could have done negative b, and you take away square root of b squared minus 4ac divided by 2a. Now if we think about what will happen for certain values of b squared minus 4ac. So if b squared minus 4ac was equal to 0, I would have had square root of 0. Now, it wouldn't have mattered if I added 0 or subtracted 0. This whole thing would just be 0. So I would just have negative b divided by 2a. So I can see when b squared minus 4ac is 0, I get only one value of this quadratic equation. Now suppose b squared minus 4ac was more than 0. So if it was more than 0, I would have square rooted a positive value. So then I could have done negative b, add this positive value, then divided by 2a. Or I could have done negative b, subtract this positive value, divided by the 2a. Let's think about what would happen if b squared minus 4ac was negative. So if this was negative, I can't square root a negative value because that's undefined. We can't square root any negative values. It's undefined for the real numbers. So negative b plus or minus square root of a negative number would not exist for us. So there will be no solutions to that quadratic equation. So if I was to write all of that down, I would say b squared minus 4ac. When this is 0, so let's say when b squared minus 4ac is 0, the equation will have one real root. Okay, roots are another word for solutions of this equation. B squared minus 4ac, so when b squared minus 4ac is more than 0, the equation will have two real roots, and when b squared minus 4ac is less than 0, the equation will have no real roots. Okay, so what we've done is, this is called the discriminant of the quadratic equation. The discriminant works as a test. Now, you can test it by finding the value of b squared minus 4ac. So b would be there, a is there, and c is there. So you find the value of b squared minus 4ac, and you're testing it. You're seeing if it equals to 0, if it's positive, or if it's negative. And for any of these, you know some things about the roots of this equation. So for this first one, I know that there will be only one real root. For this second one, I know that there will be two real roots. And for this last one, when it's negative, I know that there will be no real roots. So the discriminant is like a test that you do with the coefficients of the quadratic equation here, and this will tell you some things about the roots or solutions of the equation that we have. Here are some questions for you to answer. The first one is, define a quadratic function with a specific example. Question 2 is, what geometric shape does a quadratic function have? Question 3 is, list some conditions for the algebraic form of a quadratic function that affect the shape of the graph. And question 4 is, what is the discriminant of a quadratic equation?